we're going to work another example dealing with the normal distribution. The lengths of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. One classic use of the normal distribution is inspired by a letter to Dear Abby, in which a wife claimed to have given birth 308 days after a brief visit from her husband who was serving in the Navy. Given this information, find the percentage of pregnancies lasting 308 days or longer. So one special piece of information we received in this problem was in the first sentence. The lengths of pregnancies are normally distributed. So without knowing and seeing the graph of this, we can assume that we can apply the normal curve or the bell-shaped curve. I just notated at the top that the mean was told to us to be 268 days and the standard deviation 15. So these are just little reminders at the top for myself. I took the bell curve and I wanted to label a few things. 268 is the mean that's going to be beneath the peak of the distribution. And then to arrive at 283, I added 15. To the next standard deviation, I added another 15 to arrive at 298. And finally, I added 15 again to arrive at 313, just to get a nice labeling of my distribution. This way I can kind of judge where 308 should fall. 308 on the number line falls between 298 and 313. And I just kind of judged slightly, where this should be. Just somewhere in between. It's not perfect. What I've done next is to indicate the percentile they want us to find. It said find the percentage of pregnancies lasting 308 days or longer. Thus, that's why I shaded to the right with the blue brush. So this is our solution. This tiny little area to the right is going to be our answer. Now, how do we determine that? Well, we can't look up 308 days in the normal table. We have to convert it to a z-score first. So I took the 308 days, that's our stopping point along the axis, subtracted off the mean, and divided by the standard deviation. So the difference on top is 40 days, dividing by the standard deviation of 15. The units cancel, and I get a z-score of 2.67. Take a minute. I'm not going to actually show you this one, but I want you to look up 2.67 in the normal table. Use your own normal table and see if you can find the value that matches up with a z-score of 2.67. Well, if you arrived at the number 0.9962, you'd be correct. If you didn't, pause this video and go back and try to see where you might have made a mistake. Now remember with the normal curve, anytime we extract a number from it by using the z-score, it's always understood to be area to the left of the z-score. So that means the 0.9962 should be inserted into this blank area on the left-hand side of 308. Now, this makes logical sense to me. 0.9962 is really close to 1. And again, 1 represents 100%. So this region here that we're not interested in is practically the entire curve. Thus, something very close to 1. So it makes sense that 0.9962 should go here and not over here in this tiny region that's a very small piece of the entire curve. Question is, how do we find that small piece? How do we find this little blue area here that's to the right of 308 days? Remember, to find area to the right, we subtract the value we get from the z-table from 1. So 0.0038 is the area in this tiny little blue sliver. I'll take the 0.0038, convert it to a percent, and come to find that 0.38% of pregnancies last 308 days or longer. So it appears to be very rare. It happens less than 0.5% of the time do women actually carry babies 308 days or longer. So, this is revealed. So, what does this lead you to believe about the wife's situation? I like to think about it this way. There's two things that could occur here. Either the wife has just experienced a very rare event of carrying a baby 308 days, which we see happens very rarely. Or possibly, now part of the assumptions in this problem is that the wife had a brief visit from her husband, and that was the time at which the baby was conceived. So oftentimes when we see a really rare event in statistics, again, 0.38% is a very rare event, it leads us to believe that possibly the assumptions under which our problem was created could be false. Again, this conceivably happened 308 days or longer. Rare event. So it's going to make us doubt the assumptions of the problem, and that is that the father of this child is in fact her husband. What might make more sense is that possibly the baby was conceived at a later date, thus making the number of days that the wife carried the baby much shorter. Now, we have no proof of this, but this is one of the big thinking strategies we'll get to in this course, which is when we observe rare events, it makes us just for a second doubt the assumptions under which the problem was built. So you can think about that. You can go with either way you'd like, but this is sort of the start of our statistical reasoning.